Hi, Emily. For your questions that you've sent me for questions 1 and 2, when you're finding the mean of x here for question 1, then what that really means is that you're finding the expected value e to the x, okay? And the definition of that is that you want the integral of x times f of x dx, with your f of x being the, sorry, I can't get my stylus to write, there it is, the f of x is your function here, okay? And so you're going to integrate that. You've got x being multiplied, you can take the 1/10 out in front, and you have x being multiplied by 3x squared plus 1. And so that's 1 over 10 times the integral of 3x cubed plus x. And so really quickly, 1 over 10 times, excuse me, the integral, which is going to be 3/4 x to the 4 plus 1/2 x squared. Okay? So that's the mean, and what you want to do is, because it's between 0 and 2 for the domain, you want to evaluate that between 0 and 2, and so we should have 0 to 2, 0 to 2, 0 to 2, and what you're going to do now is sub in 2 for x and evaluate this whole bracket here, and then sub in 0 for x, which will give you 0, and subtract those two values. And so really it's just going to be the value of 1 over 10 times this, this bracket, evaluated at x equals 2. For the variance, your variance formula is going to be using the same thing. We have e to the x squared, e of x squared, and then the expected value all squared. Okay, so the difference between those two things is you want x squared. In the first one, you want the expected value of the x squareds, and the second one is that you want e to the x all squared. In this case, because you've got the, you already have the e to the x from your antiderivative, your integral from the first part, then the only thing that you need is the e bracket x squared. And how you find that is it's actually the integral, let's see if I can write on here, the integral of x squared f of x dx. And so if you go through the same steps that we did in the first one, then you'll end up with your e x squared, okay? And you're just going to subtract those two again between x equals 0 and x equals 2. You're going to evaluate to actually find a numerical value for the variance. I hope that that helps you with this one. There's also a good video that's a problem that's very similar to the one that you're working on that I found for you, and I will include the URL for that in the email also.